Welcome back to AP Chemistry with Mrs. Mays. We're working on acid-base equilibrium, and now we're going to take a closer look at salts. You probably never thought about salts as being acidic or basic, but truly the only neutral salts are those that are made from strong acids and strong bases put together. Salt hydrolysis involves the cations or anions of a dissolved salt removing hydrogens or donating hydrogens to the water. How does this happen? So if a solution is either acidic or basic based on the direction of hydrogen ion transfer, then how would a salt add hydrogens or take hydrogens away? Let's see exactly how this happens with salts that react with water. So sodium acetate is the salt formed from the sodium ion together with the acetate or ethanoate ion. And as this dissolves in water, it's going to break apart completely because sodium salts are always soluble into sodium ions, Na+, and the acetate ion C2H3O2. Now the sodium ions we just ignore because they are spectator ions. They don't do anything in the reaction. But as acetate ions enter the solution, then they have the ability to accept a hydrogen from the water. So that hydrogen moves from the water to the acetate, forming acetic acid and leaving hydroxide ions behind. So if we have a 0.14 molar solution of sodium acetate that breaks apart completely, then my initial concentration of acetate is 0.14 molar. Water doesn't get to be in the equilibrium, but then the acetic acid, the conjugate acid of my salt, and then the hydroxide ion, they start out as 0, but they're going to gain some as this accepts the proton from the water. So I have 0.140 minus x, x, and x. Alright, then we write the equilibrium expression. So Ka is the acetic acid concentration, the conjugate acid for my basic salt, and the hydroxide ion concentration over the acetate ion concentration. And I don't get to use a Ka here because I have hydroxide. I have to use a Kb. What did they give me? They didn't give me anything. We used acetic acid before. The Ka value from acetic acid is 1.8 times 10 to the negative 5. And I know that Kw is the product of Ka times Kb. So I can get my Kb value by taking Kw divided by Ka, right? Yeah. So I would take 1.0 times 10 to the negative 14 divided by Ka of 1.8 times 10 to the negative 5. So Kb equals 5.56 times 10 to the minus 10. And that we get from our equilibrium expression here, x squared over 0.140 minus x. And I can safely say that this x is too small to make any difference because minus 10 is a really small amount. So I can use the small x assumption to solve for the value of x. So let's get the calculator and take care of that. And I don't really need my solver here. I just need to multiply by 1.4 and take the square root. So let's do that. The square root of 5.56 times 10 to the negative 10 times my initial concentration of 0.140 And I get 8.8 times 10 to the negative 6. So that's the molarity of X. Now let's do the pH, because pH is not the same as pOH. This X is equal to the hydroxide ion concentration. So my easiest way to get the pH is to first start with the pOH. So pOH is going to be the negative log of the hydroxide ion concentration, or the negative log of X. So in my calculator, I take the negative log of the answer that I had before, and I get 5.05. So the pOH is equal to 5. And the pH is equal to 14 minus the pOH. So 14 minus 5 is 9. So sodium acetate in water makes a base because it pulls the hydrogen ions off the water, leaving hydroxide ions behind.